GC workshop. Okay? Okay, I'm a bit nervous because this is my first lesson. I'm on TV. Okay, first time I've a recorded lesson this way. Okay, now, first of all, I would like to make a remark. Okay, I'm sure all of you know that having important skills for GC is very crucial to scoring well for your AP exams. Okay, so same goes for our final exam because we also need GC. Right. Now, I have to make a disclaimer. Okay, I'm not working for Texas Instruments. Okay, so if you ask me the very advanced functions of the GC, I do not know. Okay, I can only tell you what are the essential functions that you need for the AP exam. Okay, and I have to emphasize that this lesson is not going to be just about teaching you the different capabilities of the GC. It's more about how you transfer the knowledge from what you learned today to the actual AP questions. Okay? If I just teach you the capabilities of GC, you must well read the whole instruction manual. Right? That's better. Right? Okay? But no. Okay? I will tell you how to actually use the GC to actually solve some actual AP questions. Okay? Right. Okay, now, unfortunately, we don't have much time. Okay, so what I need your help is, don't need to switch on your GC yet. Just hold your GC with you. Okay, all I need you to do is pay attention for the first 30 minutes. Then later I'll give you some hands-on practice. Okay, at most you'll just be required to look for the respective buttons on your GC. Okay. Now, I'm not going to touch on this scratch pad thingy. Okay. Usually what you can do is you can just open a new document, then you can add calculator or graph. Okay. So I will just be using this. Okay, so let's take a look at the most important part over here. Okay, part 2, which is on the next page. Now, the first thing that you need to know is how to key in the expression. Okay, this one, I think some of you should already know this. Things like sin x. Okay, if you look from your handout, right? Okay, let me just open a new document, add a calculator. Okay, so even for simple functions like sin x, okay, you need to put a bracket over here. Okay. Now, how about for sin square x? Okay, sin square x, right? Unfortunately, you cannot key in this way. Okay, the square you cannot put here. You have to put sin x, then whole thing bracket square. Okay, so you can see it from the handout. Okay, and for the exponential, oh, this is a real life situation. Last year during the exam, okay, we have some students who typed the E, but they use the wrong E. Okay, so what do I mean? Okay, let's say you want to type e to the power of x, right? Okay, now you cannot use the e over here. Okay, you see this e? Okay, don't use this e. This e is just a letter to store some value. Okay, the actual e you can find it over here, or you can find it using this pi button over here. Okay, so just to refresh your memory, okay, you can choose this e. Okay. Now, how about other things? Okay, now this, you see that you have this button in your calculator. Okay, let me just show this part over here. Okay, just beside the number 9, okay, on the right side of 9, there are 2 buttons over here. You can find a library of functions. Okay, so let me just show what are some of the common things. Okay, like things like fraction, square root, okay, e to the power of something of, okay, log, modulus, derivative, okay, summation, I don't think you'll need, okay, limit, okay, you'll need all this, okay. Okay, now, the good thing about our calculator is that you also have these buttons. If you want to copy expression, you can press Ctrl C. Then, if you want to paste, you can press Ctrl followed by V. If you want to undo, you can press Ctrl by Z. Okay, you can now because your calculator is not a mouse. Okay, so if you want to select some portions of the expression, you can actually hold down the shift button, then use the cursor. Okay, let me demonstrate it. Okay, this one. Okay, let's take a look at this example. Now, let's say I want to find the limit of sine cube x plus mod x over this whole thing as x approach 0 from the left. Okay, so let me just type this thing. Okay, just show once. Okay. Okay, here you need an absolute value. Okay. Okay, then after that you can press enter. Okay, so it will give you this expression. Okay, in this case it gives you 1. Okay, now how about for the next portion? Evaluate this limit, but I change the x approaches 0 minus to x approach infinity. Okay, so I just need to modify this part, right? Okay, now what you can do, right? Actually, your calculator has many shortcut buttons. Okay, so you don't really have to retype the same expression again. Okay, you can just select this part. Okay, you can just shift your cursor. Okay, if you look at this touchpad over here, right? Okay, you can just press up. Okay, so that you'll go up. Okay, then after that you can hold down the shift button. Well, keep pressing. Okay, let's say your cursor is really here. You can hold down the shift button, then keep pressing right. Okay, so ultimately you'll select this whole thing. Okay, then after that you just press Ctrl C and Ctrl V. Okay, to copy and paste. You alternatively there's a shortcut button. Do you all know? Just press enter. Okay, it will not evaluate yet. Okay, and from here, all you just need to do is you modify this part. Okay, again, all you need to do, you just go to this touchpad over here. Okay, there's this center button that acts like a mouse pad. Okay, just use your fingers, scroll to the desired location. Okay, so let me just be careful. Okay, so this is infinity. Okay, so you can find infinity over here. Then press enter. Okay, it will give you 0. Okay, so the significance of this is that the line y equals to 0 is a horizontal asymptote of the graph of y equals to this thing over here. Okay. Okay, now let's take a look at the next page. Okay, the part 3. Later can I look for you? Sorry, I got to finish the lesson. Sorry. Okay, now the next part is about this changing to degree mode and radian mode. Okay, this one I won't touch on this. Okay, you can read through it yourself. Just understand that when we talk about differentiation and integration, everything must be in radians. Okay. Now the more important part that I need you to focus on is actually this bottom portion over here. Now, do all of you know that in your actual AP exam, for any non-exact answers, you are supposed to round off to how many decimal places? 3. Please remember this. Okay, this one is not physics. Physics, I know you all round off to 3 significant figures. Okay, for AP calculus, you have to round off to 3 decimal places. Okay? And for intermediate working, you have to round off to at least 4 decimal places, at least. Okay, so just to let you, okay, I'm sure all of you have roughly seen this in your journal. Okay, if you have done your journal last year, okay, you will have encountered how to change the float settings, right? Okay, so you can actually adjust by coming to this document settings. Okay, so you can read the instructions here. Okay, I won't go through in detail. Okay, so this one will skip. Okay, now the next part is how do we evaluate the definite integrals? Okay, so this one actually there's more than one way to do it. Okay, so you can, for example, here, okay, you can, for example, press menu, then go to calculus, and go to integral. Okay, this 3 steps. Menu, then select 4, then select 3. Okay, then you'll get this integral. Okay, or alternatively, you can just press this button over here, okay, which I mentioned just now. Okay, you can get from here. You can also see this over here. Okay, so let me just press escape. Okay, so let me show an example for the exercise 3. Okay, you can take a look at this question. Now, this question is similar to your holiday homework. Yeah, it's similar to your holiday homework. Okay, unfortunately, many of you didn't do it the way we actually intended to. Okay. Okay, now this is the velocity function, sine of t squared. Find the average speed of the particle from t equals to 1 to t equals to 5. Okay, I know we seldom touch on average speed. Basically, average speed is just the total distance traveled divided by the total time taken. Okay, so now let's try to use the GC to actually evaluate this. Okay. Now, first of all, right, you need to find an expression for the total distance traveled. So all of you should know that to find distance traveled, okay, you need a modulus. Okay, this part is the modulus. Okay, then you have sine of t squared. Okay, then dt. Then from t equals to 1 to t equals to 5. Okay. This expression alone will give you the total distance traveled from t equals to 1 to t equals to 5. Okay, so if you want to find the average speed, okay, you just need to multiply by 1/4. Okay. Okay, so it will give you this. Okay. Then for the next part, okay, let's take a look at another common kind of AP question. Okay, this one is on this thing called first fundamental theorem of calculus. Okay, you have the position of the particle at t equals to 0. Okay, at t equals to 0, the particle is at x equals to 3. Okay, and you are supposed to find the position of the particle when the time t equals to 7. Okay, given the velocity function above. Okay, so you can use the first fundamental theorem of calculus. Okay, so let me just show roughly what this is. Okay, basically, this is what I was referring to. Okay, the first fundamental theorem of calculus. Okay, the final position is the initial position plus the change in the position. Okay, this term is the change in position. Okay, so you just start this whole thing accordingly. Okay, you can get your answer. Okay. Okay, now let's take a look at this part on solving equations. Okay, first of all, let's take a look at this equation. X to the power of 4 minus 3x plus 1 equals to 0. Okay, so I need to show both methods. Okay, because there are advantages and disadvantages, okay, of each of the method. Please make sure you know both. Okay, later you'll understand why. Okay. Now, first of all, all of you roughly know about this solve function, right? Okay, so let me just type. Okay, it looks something like this. Okay, let me just retype this part. Okay, solve. Okay. Then x to the power of 4 minus 3x plus 1 equals to 0. Okay, and put a comma x. Okay, because I want to solve for x. Okay, then just press enter. Okay, so it will give you all the possible real roots of this equation. Okay, now, what if I want to further restrict the domain? Okay, this one is not in your notes, okay, but if let's say I just want the value of x that is, say, more than 1, okay, so all you just need to do is, okay, come to this expression, okay, let me press enter again to copy. Okay, now, from here, right, can you find the button, okay, let me just... Okay, what I've just done is I press the control, then followed by the button below here. Okay, then you will see that this window will pop up. Okay, please select this vertical stroke over here. Okay, it looks something like the evaluated at that function. Okay, so you just press this one. Then let's say I want those values of x that are more than 1. Okay, so you can press x. Then more than 1, then it will just give you the answer that you want. Okay, so to help you restrict your domain. Okay. Now, the second method is more intuitive, though it may look a bit tedious. Okay, what you can do is you can just simply sketch the graph of y equals to x to the power 4 minus 3x plus 1. Then from there you find the x-intercept. Okay, so let me just show once. Okay, so I got to open a new page and add a graph. Okay, let me type x to the power 4 minus 3x plus 1. Okay. Then from here, right, you just need to find the roots of the equation x to the power 4 minus 3x plus 1 equals 0. That will correspond to the x-intercept of this graph. Okay, so you can actually access by pressing this menu, then go to analyze graph. Then here you'll see many things, right? Okay. So here I'm going to select this option here, 0. Okay. Actually we'll be using this quite often. So remember, menu followed by analyze graph. Then you have all these options. Okay. So for x-intercept, choose the 0. Okay. Then after that you need to choose a... Let's say I want to find the x-coordinate at, say, this first x-intercept over here, the one which is the leftmost. Okay, you have to choose the lower bound. So you can use your cursor, okay, this touchpad over here. Just scroll to the for lower bound. Okay, that means you can choose somewhere to the left of this x-intercept over here. Okay, does not really matter how much you choose. Just select a point where it's not too far away. Then just click once, okay, by pressing the touchpad once, okay, at the center button. Okay, then after that you just scroll to the right, okay. Then you'll see this thing comes out. Then select again, okay. So if you cannot follow, not to worry. Okay, later you can have some hands-on practice. Okay, the learning doesn't just stop today. Okay, you must continue to practice. Okay. Same thing. If you want to find this x-intercept over here, you can press menu, analyze graph, 0. Then after that, just repeat the same process. Okay, now here you see one issue. Okay, if I ask you for the x coordinate over here, and if you are supposed to express in 3 decimal places, okay, that's why you need to change the float settings. Okay, so I must well just change now. Okay, so you can write 1.307. Okay. Okay, now later I will tell you why you need to know method 2. Okay. For now, let's take a look at this example. Okay, this exercise is a bit tough. Okay, because you all haven't learned chapter 3 yet. Okay. Sorry. Okay, can I find you later? Okay, for this exercise 4. Okay, let G be defined by this function over here. Okay, this kind of function, there's a name for it. It's called the area so far function. Because it calculates the area from t equals to 0 all the way till t equals to x. So you input any x value, it's the same as you input the x value over here, then it will calculate this area. The area that it calculates will give you the value of g at that x coordinate. Okay, so now, obviously, right, if you attempt to type this whole thing into the calculator and you graph it out, okay, it's going to take some time. Because every time you need to calculate a value of gx, you need to integrate. So imagine the processing time required. Okay, so most likely if you go and press this and key in to graph it out, okay, your calculator may hang. Okay, so here is where you need to know. Okay, what if the calculator hang? Do you all know how to interrupt the calculation? You can actually just hold down the on button. Just hold down this on button for maybe 4 seconds. Then it will tell you calculation interrupted, something like this. Then after that, please, before you go back to the same document, please delete the document that just now you have hanged. Otherwise, when you reopen the document, it will hang again. Okay. Okay. So now, what do we do, right? Now, one of the important takeaways for this lesson is that you should try to work on the graph of g prime. Okay, don't bother about the function g. Bother about the function g prime. How does the graph of the derivative of g look like? Okay, this concept will be used very repeatedly. Okay, I've seen many AP questions. They all need the analysis of the function g prime. Okay, so you haven't really learned how to differentiate this kind of expression yet until you go chapter 3. Okay, but anyway, I'll just show the answers. Okay, let me see. Okay, so here, okay, if you attempt to differentiate this whole thing, what you're going to get is this graph, cosine of 1 minus sine x over 2. Okay. So from here, what we can do is actually we just need to graph out the graph of y equals to g prime x instead. So you have a graph that looks like this. Okay. Now the advantage is that from here, if you want to find the x coordinates of the relative minimum of g, okay, just recall that you can use the first derivative test. Okay, at the relative minimum, what must happen? The g prime x must change from negative to positive. Right? Negative to positive. Okay, so look over here. Here I will target these 2 points. Okay, you have this point and this point. So you should be able to pick the correct point. Oh, okay, there's also another point here. Okay, so if you want to find the relative minimum, I mean the x coordinate of the relative minimum, okay, you should actually choose this point instead. Okay, because at this point, you can see that the the G prime changes from negative to positive. Okay, as in this portion of the graph is below the x-axis, this portion of the graph is above the x-axis. Okay, then after that, if I ask you for x coordinate, you just need to go to the 0. So just now go to the analyze graph, select the 0, then you can get the x coordinate of this point. Okay, that will be the x coordinate of the relative minimum of G. Okay, and same thing for relative maximum, you can choose this point and this point. Okay, so here you have two relative maximum here. Okay. Now, the next part is on adjusting the window size. This one will be very important. Okay. Now, sometimes, unfortunately, when you graph out, if you want to focus on some portion, okay, you may not get the ideal picture that you want. Because sometimes the graph is really too squeezed that you can't really notice too many things. Okay, like, okay, maybe let me just show you. Okay, this one, the example is still not too bad, but here you see that this part is a bit too close to the x-axis. Okay, if you can't see very clearly, you can always just readjust the window size. Okay, so let me show this. Okay, please remember this well. Okay, because sometimes the AP will ask you questions on finding, say, x coordinates of relative minimum at, say, between x equals to 15 to x equals 20, for instance. Okay, then obviously, if you go and see where's 15 and where's 20, they are all over here, right? Okay, it's already outside the window range. Okay, and also, I don't really recommend the zoom out function. Because if you zoom out, right, then everything looks too small. Okay, so I prefer the custom zoom. Okay, so let me just illustrate this point. Okay, so first of all, let's take a look at this exercise 5. Okay, how many critical points does the function f have on the interval 0 to 20? Okay, if its derivative is given by f prime x equals to this. Okay, now again, don't bother to go and integrate this function and graph it out. Okay, I do not know how to integrate this. Okay, so all you just need to do is you graph out the function f prime instead. So let me just show once. Okay, then let's see what will happen if you do that. Okay. Now here, unfortunately, you'll get something like this. Okay, you can't really see very clearly where you will intersect the x-axis and how many times you will intersect. Okay, it's also not very clear. Okay, but look at the question again. Okay, the question asks you to focus on this interval 0 to 20. Okay, so you can actually go to the window. Okay, from x equals to 0 to x equals to 20, you adjust accordingly. Okay, so you can go to, wait, let me see, menu, then window, then go to window settings. Okay, see? Menu, window, then window settings. Okay, then after that, select the x minimum to be 0, select the x maximum to be 20, then press OK. But even then, okay, can you see what's the issue over here? Yeah, everything is too close to the x-axis that you can't really see properly. So this time around, I want to do a scaling parallel to the y-axis instead. So for the y minimum, right, okay, I will choose somewhere around here. Then for the y maximum, I'll try to choose somewhere around here. Okay, so that you can really stretch the graph. Okay, so okay, so y minimum. Okay, let me just put a number, say -1. Okay, y maximum. Let me put 1. Okay, now this time around, do you agree that it's much clearer now? Yes, right. Okay, so now, here I can answer the question already. Critical points, if you recall from last year, it refers to those points where f prime x equals to 0 or does not exist. But this is already the graph of y equals to f prime x. Okay, so you just need to look at the x-intercepts. Basically, for this example, you don't really have any points where f prime x does not exist. Okay, it's actually, okay, here you have one point here, and another point here, and another point here, where the graph of y equals f prime x intersects the x-axis at, yeah. So actually you have three critical points in total. Okay, right. Okay, now let's try another question. Okay, for the same function f defined above, how many inflection points does f have on the interval 0 to 15? Okay, so here let me just readjust the window to 0 to 15 again. Okay, now you please don't go and solve like f double prime x equals to 0 or whatsoever. Okay, it will take too much time. Okay, you just readjust the window. Okay, let me see. Menu, and the Windows settings. Okay, then press OK. Okay, so just recall this thing in your notes. Okay, this will be very useful for this type of question. Okay, remember what does it mean by concave upwards and concave downwards? Okay, this is the definition. Okay, we say that a function is concave up if the graph of f prime is increasing on the interval I. And the graph of f prime, if it's decreasing on the interval I, we say that f is concave downwards on the interval I. So I'm just going to look out for the regions where f prime is increasing or f prime is decreasing. Okay, so here, since we have already sketched the graph of f prime, okay, so you can see from this graph, okay, from here all the way to here, okay, the graph of f prime is decreasing. Okay, and from here to here, the graph of f prime is increasing. So at this x coordinate that corresponds to this point over here, okay, it corresponds to a point where the graph of f changes from concave downward to concave upwards. Okay, so the x coordinate here will correspond to the x coordinate of the inflection point of the function f. Okay, so of course, if you want to find the coordinates here, you can always go to menu, analyze graph, and go to this. Okay, this minimum here refers to relative minimum. Okay, so you can go to calculate this minimum, relative minimum of this, then you'll get this point. Okay, so you can conclude that x equals to 1.571, okay, will correspond to an inflection point, okay, of the function f. Okay. Now, same thing, you can see that the relative extremes of the function f prime, okay, will actually correspond to the inflection points of the function f. Okay, so you actually have a few more inflection points. You have this point, then here you have 2, then here you have 3, then you have 4, 5, 6, then 7, 8, and 9. Okay, right. Okay, so basically that's about what I need to show. Okay. Okay, at first my intention is to actually let you all practice some hands-on practice. Okay, but I don't have much time. Okay, so maybe can you take a look at the exercises? Okay, you try to do as many as possible, then try to go through what I can. Okay. Alright, for the first one, you have to use this limit definition. F prime 0 is limit of fx minus f0 over x minus 0 as x approach 0. Okay? Okay, so let me show the answer first. Okay, for the fx, right? This fx, you should use this portion over here. Okay, don't go and use the e. No. Okay, you have to understand that when we talk about limits, okay, it's the surrounding that is important. The surrounding information about the function f. Okay, at x equals to 0 itself, I don't care how the fx looks like. Okay, okay, for this part, okay, you should take this part. Okay, this is the surrounding. Okay, what happens to the function f near x equals to 0? Okay, and for f0, you should refer to this and select the e. Okay, so let me show the answers. Okay, so this is the required answer. Okay, just type this expression into your GC, then you get minus e over 2. That's your gradient at x equals to 0.
So realize that the GC can be used to calculate the derivative using definition.
Okay, for the next part, okay, f prime x is e to the power x minus 3x squared. Okay, so let me just type this. Okay. Okay, so for relative maximum, firstly, right, for this graph, okay, the relative maximum occurs when f prime x equals to 0. Okay, so here you have three possible candidates. Okay, you have this point, you have this point, and you have this point. Okay, but here because they ask for relative maximum, so f prime must change from positive to negative. So it's only this point over here. So you can roughly guess the answer is around 0.9. Okay, but if let's say you want to calculate the exact value, okay, just go to menu, then analyze graph, and go to this 0, then select and select. Okay, you get 0.910, right? So that's the answer for the second question. Okay, so answer is C. Okay. Maybe we just try one more. Okay, unfortunately, I need to dismiss you soon because you have the PE. Okay? Oh no. Okay, anyway, just roughly flash the answers. Okay? Same thing, you just need to sketch y equals to f prime x. Okay? Y equals to f prime x. Don't need to differentiate or integrate or whatever. Then just analyze from here. You need to adjust the window settings, definitely. And you need to look for the interval where f is concave down. That means for this graph of f prime, look at where is it decreasing. Okay, it's decreasing from here to here and decreasing from here to here. Okay, so that's why the answer is D. Okay. 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 So thank you very much.